Welcome to a new test and teardown video. We're still playing with homebrew equipment, and I think what we got here, that will just be like frequency standards in a box. So you can imagine in the old days when you didn't have super accurate equipment, but as long as you got something that was accurate, you could always recalibrate your own equipment or dial it in to transmit or receive at a wanted frequency. So we got those three units, and this one I think is the most interesting, UHF generator. So we got level and a frequency dial. So that means you could take this somewhere, dial in the frequency and the level, and bring it back home and then repeat the test. So I think this is very old. It looks like this one can do 2.5 watts. 12 volts, 600 milliamps, and this will be the frequency range. So that covers the entire 70 centimeter band, obviously, for the radio amateurs. So let's try and connect that one first and see if there's anything left in that one. Okay, yeah. So I'm playing a little bit here with the, what is that? Is that the, ooh, yo. Holy smokes. So that is 1 watt of output. Let's hammer it all the way up. 33 dBm. Oi. And look at the harmonics, what happens when I turn down the power. Then suddenly, oops, the harmonics just go away. So as long as we just keep it to 0 dBm, the harmonics they're gone in this view. But the knobs here are like really easy to move. Yeah, and it's the same with the frequency. I think we're gonna zoom in a little bit and see how accurate it really is and how stable it is. So yeah, I think I did it right. The pot here is in the middle, and yeah, so that is 435, and I just did a 10 megahertz span, and look at that. It feels like it's really nice and stable, and the amplitude is just dropping a little bit, like barely visible. So let me put this in the middle again. And I think I'm going to turn this on and off and see what happens when it's like cold and hot. So I will be back in a minute. So now it is cold, and I'm going to power on the 12 volt supply now. So this is the warm-up sequence. Remember last time I played with this, I didn't touch anything. The peak was in the middle of the screen, and okay, this is a 1 megahertz span. So obviously this is just a peak generator for I don't know, really, a spectrum analyzer, or I don't know, something that doesn't really need to be super accurate maybe. It could also be used for a antenna sweeper or an antenna SVR analyzer, or SVR bridge, and then a voltmeter, right? So you could sweep some antennas. then of course it doesn't need to be super accurate, but it's actually quite stable when it's warm again. Let's try and play with the voltage. So this is 12 volts, and I'm now stepping 100 millivolt up and down, up and down. So that is 100 millivolts, and then 100 millivolts down. And let's 2, 3, 400 millivolts down. And let's go back to 12 again. 12.1, 0.2, 0.3, 0.4. Let's go back to 12. So that means the supply voltage is affecting the oscillator frequency. That is a little bit interesting. Let's try and play with the level and see if the level affects the frequency. No. Oh, yeah, it kind of does, right? Really? That is interesting. I mean, look at that. How it's behaving. I mean, I can't wait. Ooh, oy, oy. So it's doing all sorts of funny things here. I can't wait to open this and have a look. How is this built? This is going to be interesting. Wow. That is actually very, very beautiful. I am impressed. Look at that. Everything is done completely out of your head. I just did it. Wow, wow. What have you got? I think down here. I think this is the VCO, isn't it? Yeah. And here we got some capacitor, some varicaps. So those diodes, they change capacitance with the voltage, and the voltage goes, of course, to the frequency. It is done with all the nice filters, those feed-through filters. I mean, totally by the book. Oh God, that will be all the way. I guess this is, yeah. And this is the output. There's even a coax that goes here from this power amplifier. And there's even a little coax here all this way. All the drivers. This is a DC biasing. I'm trying to figure out the power path is this way, right? But there's also a biasing or something like that. This transistor here is doing some sort of biasing for this one, right? Well, this is a current regulation for that one. I've got a little filter here as well. And then again, beautiful. Imagine how many hours it took to get this one working and actually that accurate and that stable without voltage regulators. Okay, yeah, we got a few Zener right here, right? So Zener diodes, I guess. Or maybe this is like a voltage regulator for this, using Zener, and I think this is the same here as well, right? Zener and probably emitter follower with a Zener going to the oscillator part, but no voltage regulators, but just transistors and Zeners and everything. And here's your output stage. Yeah, I am very, very impressed. We gotta see how the others look like. I mean, first we need to power them up and see if they really work, right? But that was actually a lot of fun. So this is one of the... Wasn't it the same kind of frequency? No, it's not exactly the same frequency, but very, very close. I wonder what is the trick about the difference here. It's 20 kilohertz apart. So that is very close. And it says 30 milliamps, so it's a very weak signal, I guess. Let's try and see what happens here. I hope you can read this. It says, can you see here? This is as close to 6 dBm as you can probably imagine. And the frequency is 14.156. And it says 155 on this unit. I mean, that is amazing. How is that possible? It is crazy accurate. Let me try and play with the... Okay, 12.1, 11.9. Okay, so nothing happens here with the voltage. Let me try and play with a much wilder step. So that is 11. Okay, output was lower. 11, 10, 9. Okay, now we're just going down. So I mean frequency. So there's a crystal in here, right? Back to 12. We gotta have a crystal. That is how it is. Let's try the other one and see if that one works as well. So this is the other one. And let's have a look. It's at 14.135, and that is very, very close as well. And that is what I would call 6 dBm. So how is that possible? And this thing is like 40 years old or maybe 50 years old or something. Oh, we gotta have a look inside. So while I'm opening this one, maybe you could think about what kind of equipment or what kind of usage, what are they designed for? Where could you use them? Like in the middle of the 20-meter band, maybe just markers so you could adjust a free running VCO receiver or transmitter or something like that. Maybe that could be a good idea. Oh, look at the filter. So oh yeah, look at that. There's even a filter for ground and a filter for positive, and capacitors here like that, and of course there is a reverse voltage diode. And I think we've seen those boxes before, right? A few days ago I released the spectrum analyzer design, and that was the same kind of boxes. They're super nice. Let's have a look inside here. Oh yo yo, that is pretty. And again, he even put in varnish or coating. See how nice and shiny everything is. That is wonderful. And the crystal is of course here, and there is no adjustments for the crystal like a VCO or something. There's only the trimmer capacitor here where you set the frequency, and that's what there is. So this is the output. I would assume the output went through some buffers or some drivers or something. But yeah. So I think the output goes that way. I think the oscillator is this kind of stuff. Goes that way, and then we go that way out. That is how it is. Look at all those filters. He was really, really super when it came to all this filtering feed through, and all those inductors, capacitors, inductors. And again, I mean, how many DC filtering have you got? I've never seen it done that well before. Yeah, I mean, it must have taken, I mean, a few days to figure all this out, right? And maybe a week to plan, and tons of nice hours went into the design of this box. And he even made 2 of them for something. We don't know exactly what it was. But yeah, that was homebrew in the good old days when you really knew how to do homebrew. Thank you for watching.